So, all right, so next week, Monday, the 2nd of May, we are still going to, I know it is a public holiday and you guys probably have like an extended weekend or something of the sort. There is still a lesson at 6 p.m. on Monday, the 2nd of May. Okay.
Thank you. So we carry on going with the public holidays. So we will be, that's important. Anything else, Coco, from your side? I'm not seeing any Maths 24 questions yet. So I want to see if we can get those. So let's see. So Lizzo, so 7 multiplied by 2. So 7 times 2 is 14. And then 14 plus 8 plus 2, you are winning. Yep. So that's Maths 24 on the blue one. And then on the yellow one, 5 minus 2 is 3. And then, so 5 minus 2 is 3. Unfortunately, this is not a 6. This is a 9 because the line is at the bottom. So, unfortunately, I cannot declare a winner yet for this yellow one. Can anybody help us? So, this is a 9 because the line is always at the bottom. Who can get... What are you? All right. So far, the yellow one here has gone unsolved, unless it comes out of nowhere later in the lesson. But I think we are ready to get started proper with the lesson. Okay. So let's just talk a little bit about what we've been doing lately. So if we go back a good couple of lessons before the grade 10 or after the grade 10 trigonometry, we dealt with something called the reduction formula, and we incorporated into this was something called the cast diagram, which I often refer back to, which tells us where different trig ratios are positive or negative. Now, the reduction formula allowed us to reduce something, say like the sine of 220 to something which is basically where this angle over here is an acute angle where you can reduce it. And so what we did a couple of lessons ago, we said, well, trigonometry has to do with triangles, and you can't have a triangle that has an angle of 220. That doesn't make any sense. Triangles only go up to 180. But what we can do is we can build a triangle in the third quadrant, and in which case the reference angle that goes with 220 is actually 40, because it's 180 plus 40. And what we said is that using the cast diagram, we know that sine is negative in this quadrant. And so the sine of 220 is the same as minus the sine of 40. Okay, so that is called reducing an angle of the horizontal. And it's an example of a trig identity, because sine of 220 is exactly the same as minus the sine of 40. And you can try this on your calculators. Now, this idea also comes up in trig equations later, but that's one example of the reduction formula that we did. Then we dealt with what are called trig equations, which we're going to carry on with tonight. And what we did with trig equations was we realized that really the first step is almost always the reference angle, which we calculate, and we ignore the signs. Then we look at the correct quadrants. And then the last step was to, well, work out answers, so find the answers. And then in the last lesson, we added something called the general solution. And the general solution was where we added on a bit that took into account the period of a trig graph. So and I'm going to show you a graph, a trig graph now, but the sine graph has a period of 360, the cos graph has a period of 360, and the tan graph has a period of 180. And so we were working with trig equations, and today I'm going to show you some more advanced trig equations that have a little bit more to do with the trig graphs. And so then just to remind you, we'll talk about trig graphs in a moment. So we've been talking about the different trig graphs. And then also in the last lesson, we spoke a little bit about trig identities. And these are going to come up later in the lesson. But the main trig identities that we deal with are the reduction formula, which I mentioned above. And then there's something called the quotient identity. So we can say that tan of x can always be written as the sine of x over the cos of x. We can make that conversion. And we have an identity called the square identity, which says the following. Now, the reason I'm going over all this at the beginning of the lesson is sometimes we have new students, but also because we are going to be using all these bits and pieces today throughout the lesson. And so it's nice to just see them up front. Okay, so that is that part. So let us look at a trig graph. And I've got a little fancy bit of technology, hopefully, that can help us illustrate what is going on here. Let me get rid of this one here. Okay, so what I want to know in the chat, oopsie daisy, pressed the wrong button. I want to know what is the trig graph that is currently on the screen. Put it in the chat. What is the trig graph that is currently on the screen? Yeah, so we call this graph y equals cos x. Okay. Now, this is a basic trig graph. You'll notice that we have quadrant 1 from 0 to 90. So we can see that, can you see that the graph is positive from 0 to 90? Then you'll see it's negative from 90 to 180 and 180 to 270. So that's why in the cast diagram, if you look at the cast diagram, you will see that cos is positive in this quadrant and negative in this quadrant and negative in that one and positive in that one. Look at the graph, how it's positive, negative, negative, and then positive. I can even zoom in a little bit so you can see it. Okay, now, what I want to look at today is if we start to do something like this. If I say to you, what is the cos, it's called a transformation. If I say to you the graph y equals cos 2x, I want to see, do you guys know what's going to happen if I type that into my formula? I want in the chat, what do you think is going to happen if I type cos 2x? Give me a suggestion in the chat. I want you to predict what's going to happen, and then I'll show you what's going to happen. So how does the graph of y equals cos 2x differ? Okay, so it actually won't go up. So let's draw in the graph of cos 2x. And so should we keep track? What was the original one? The original one was the purple one, huh? What can you see the red one? What has happened with the red one? Look at how it goes down and then up and then up. What has changed between the purple and the red graph? So I think it's almost like the graph got pushed together. We say that there's been a change of period. The graph no longer goes for 360. Let me just move this a little bit. So can you see with the purple graph, it goes 90, 180, 270, 360, and it finishes a whole cycle of down, down, up, up. With the red graph, what's happened is when you put a 2 in front, you essentially you compress the period. The period of this new graph is no longer 360. The period is going to be 180, whereas it used to be 360. it used to go in steps of 90. Can you see it's now going in steps of 45 degrees? And so what if you change the number in front of the x? We call that a period change. The period has changed from 360 to 180. And I want to point out why this is important for trig equations. So let's say, for example, I have the equation cos of x equals, I think I've done this so many times, cos of x equals a half. Let's say I'm solving that equation. If I want to visualize the answer to that, it's going to be where, let me put this in a half. Oh, did I not draw it? Let's have a look. And let's change the color to something different. Let me take the purple, let me take the red one away for a moment. Okay, now what I'm visualizing is if you want to know what the solution to the equation cos x equals a half is, it's where the two graphs meet here. So the one answer is going to be at 60. The one is going to be at 60 over there. Can you see it's 60? And then the other point is going to be at 300. So that's why the solution to this trig equation is 60 and 300. But what happens if instead of having the equation cos x equals a half, I now have the equation, and apologies if I'm going a little bit too deep here, but I think it's good to just kind of, if the equation is now cos of 2x equals a half, is my solution, is it going to stay the same? And I want you to think about that. Before I show you the answer, do you think the answer is still going to be, what did we say the answer was? It was 60 and 300. Or do you think it's going to change because of the 2x? Because I want you to think about that for a moment. And then I'm going to show you the answer now. I want you to predict in the chat. Say, if you think it stays the same, say the same. If you think it changes, put your answer there. It's going to change. No, it's going to stay the same. Okay, let's have a look. Instead of showing you the graph of, okay, so now we've still got my line of a half. What's the answer going to be? Well, the answer there is going to be 30 degrees. And the answer here is going to be 150 degrees. Ooh. So I want to point out that, and not only that, can you see how the answers don't repeat themselves every 360 degrees? If you look at the period of this graph, the period of the graph is 180. So you have an answer here and here, and the answers occur every 180 degrees. They don't occur every 360 because of this 2 in front here. So this is a new idea, and I just wanted to show you it in the graph form before I show you an actual trig equation like this. Okay, so that's all I wanted to do. I wanted to show you that if there's a 2 in front of the x, it not only changes the period of the graph, it also affects the answers. And so now what we're going to do together is we're actually going to solve a trig equation that shows us how this works. In fact, let's solve the same trig equation that we did above here, using the method we learned in the last lesson. Okay, so I'm going to get rid of, let me leave it up here. So let me make this shrink so that it doesn't get in the way. Oh, what am I doing here? Give me a second, guys, while I just quickly make this smaller. And then my idea will stay the same, but we'll focus now on the algebra. Okay, so this is what I wanted to show you, something different. If we look at cos 2x equals a half, we did this in the previous, let's solve this question using the method from last time. So what is the reference angle going to be? Now, at the very beginning, all we're going to do is we're still going to type cos minus 1 of a half. So my reference angle is going to stay the same. So shift cos 0.5 and we get 60 degrees. But now the difference is that we are going to put, well, we're going to put a 2x here instead of, well, actually, we'll bring this later. Let's do this first. First of all, let's keep it at 60. Now, what quadrants is cos going to be positive in? It's going to be positive in quadrant number 1 and quadrant number 4. So in quadrant number 1, the answer is going to stay 60. And then in quadrant number 4, it's going to be 360 minus 60, which is 300, essentially. Now you'll notice that I haven't changed anything yet. So how is this change that I'm making such a big deal about meant to come in? And so this is what you need to do now. In the last step, we are going to write, instead of writing x equals, we are going to write 2x equals. Notice the difference, guys. So can you see how before it used to just be x? Now, because there's a 2x in the question, we write 2x equals 60. And we're going to leave it like it used to be k times 360. Or over here, 2x is going to be equal to 300 plus k times 360. And this is what we did in the last lesson, where k is an element of the integers. But there's one extra step we need to do now. The extra step is that we need to get rid of this 2. And this is where the whole thing comes together. If we divide both sides by 2, 60 divided by 2 is 30. And what is 360 divided by 2? It's going to be 180. Over here, what is 300 divided by 2? Okay, so if I divide both sides by 2, I'm going to get x on this side, and I get 150, and then I get k times 180. And so this is a more difficult trig equation where there's been a period change in the question. Now, I want you guys to do a similar type of question to this, but before I let you go and do it, I want to make sure that if there are any questions. So if there are any questions in the chat, Coco, from you or from any of the students, because what I'm going to do now is I'm going to set you a question below and ask you to solve it using the method I just showed you.
Well, none at the moment. So
okay.
I think we're kind of getting.
So I want you guys to solve this trig equation. Cos 3x equals minus 1 over 3. So this is a trig equation. If we had to visualize it, we draw the graph of y equals cos 3x, and then we draw a straight line of minus a third. I want you to try and solve this trig equation, find the general solution, and I'm going to leave the one above up on the screen so you can mimic it as you go through the process. Can you all see okay? Coco, can you see okay?
Yeah, that's all good.
Okay. Because the thing is, it is important that we look at some of the more complicated trig equations, but the method is almost the same. We just modify it slightly. And I'm going to give you 5 minutes to do that. So ask yourself, what is the first step? Okay, where does it go from there? So you should have got that as your reference angle, but now you need to think, what does the next part look like? So Karabo, I'm keeping quiet to give you a chance to practice for the most part. But if you have a question, pop it in the chat and I will respond. So what quadrants is cos negative in? Yeah. So I think cos is, we can even draw a little cos diagram. So cos is negative in that quadrant and that quadrant. And so I like to do my Roman numerals. So what do you think I'm going to do next? So I'm going to go 180 minus this. And this one is going to be 180 plus that, yeah. So what do we get? We get okay, but we're not completely finished yet because we still have to incorporate the 3x. What is the 3x doing with anything? 250.5. So now, in this last step, we need to bring the 3x in. And we say 3x is equal to 109.5 plus k times 360. I know this is getting a bit of a mouthful, or 3x. So notice how I'm just taking this thing that was here and it's suddenly reappearing here. So 3x equals 250.5 plus k times 360. So I'm leaving the period the same for now because it's going to be adjusted in a moment. And then we have to divide both sides by 3, which means we get 36.5 plus k times 120, or 250.5 divided by 3 is going to be, so x is 83.5 plus k times 120. And just to make sure that you believe me, if you put x back into that original equation, you will see 3 times 36.5. You apply cos, you get minus a third. Yeah. Okay, so that is a little bit of a trickier trig equation with what I will call a period change, where the graph essentially compresses. Why is it 120? Great question. Can you see that the 3 has disappeared? So when I divide the 109.5 by 3, I get 36.5. But it's not just the 109.5 that needs to be divided. So in Bali, where did I get the k times 360? All right. So the k times 360 is because the cos graph has a normal period of 360. That's how much the normal period of the graph is. However, in this question, because there was a 3 next to the x, and I divide both sides by 3, the period is changed from 360 down to 120. Okay, so I hope that helps a little bit. Basically, the 3, yeah, how is the second one 83.5? So in the second one, I had 250.5 as the thing I started with. So that was the answer that I had. I said 3x equals 250.5. But then if I remember, there's this, Let me bring that back. Remember, there's a 3x, and that 3x has to become a normal x. So I divide both sides by 3. So what is 250.5 divided by 3? And we get 83.5. And then what's 360 divided by 3? It's 120. Okay. I want to try one other trig equation. I'm not going to explain it as much, but I'm going to let you, well, I'll do one example and then I want you to practice it. But I think we've covered this one in detail, so we can move on. If you look at these are some other questions that I prepared ahead of time. Now, there's a slight difference. We have just done a question like this one. So I'm not going to do it with you right now. And this one is the same family. Can you see how the number in front of the variable is changing? So that's what I wanted to show you. But now, what about a question like this? We've never dealt with a trig equation like this before. And so I'm going to do an example, and then you are going to do this one down here after I've done an example. Okay, so let's just watch what I do. So I'm actually not going to show you on the trig graph, but this particular effect is this shifts the graph 25 degrees to the left. So this is called a horizontal shift. It's not a period change, it's a horizontal shift. And so if you drew it on a graph, you would see the graph almost moves to the horizontally. But for us, that's not really important. My question is, how do I solve this? So the good news is, step one is you find the reference angle, which is going to be the inverse cos of 0.231. So shift cos 0.231, and I get 76.6. Then I ask myself, in what quadrants is cos positive? Notice how this is a positive number. So I think cos, and no harm in doing a cos diagram, it's going to be here and here. So my answer is going to be, I'm in quadrant 1 and quadrant 4. And so the answer would be 76.6, or it's going to be in quadrant 4, it's going to be 360 minus 76.6, which is 283.4. Now, you may be asking yourself, how do you find I haven't used this thing at all yet. And so where does that come in, and where does the general solution come in? So all we do now, just like before, is we take the thing that is enclosed inside the trig thing, and we just make it equal to the number answer we have there. So can you see theta plus 25 is 76.6. And then for the one in quadrant 4, I'm going to get theta plus 25. Let me make that smaller. Theta plus 25 equals to 283.4. Now, I'm actually not, if I wanted to add the general solution bar on, I would just add on the k times 360. Because of time today, I'm not even going to do that. I'm just going to leave the answers in the form. But basically, I've got the theta plus 25, which is hanging out on both sides. And so in order to adjust the answer, all I need to do is take away 25 from both sides. And so the answer is going to be 76.6 minus 25. I'm taking away 25 from both sides, so I get 51.6. Or on the other side, 283.4 minus 25, and I get 258.4. If I wanted it to be a general solution, I would just add on k times 360. But in this type of question, there's been no period change. There's just been a horizontal shift. Okay, I want you guys, I know that was quite quick, but I want you to attempt to do this one over here. Solve the equation cos alpha minus 25 equals I want everyone to solve that, and then we can have a break. Then I think we've solved enough trig equations. I've covered enough with you that you should be able to solve most of the things that come your way. So just a reminder, you're doing the red block. And I will be quiet, but if you have a question, put it in the chat or come and chat to me online now, and I will do my best to help you. Otherwise, I'm getting some water. Cool.
Sir, I think Cameron has a question.
Go ahead, Cameron. Yeah. Do we use it to the third decimal place? So normally your exam will specify like 2 decimal places or 1 decimal place. I'm just using 1 decimal place. Oh, actually, I suppose here I rounded to 1 decimal place. Basically, you follow the orders of the exam. Most of the time, it's either 1 or 2 decimal places. It's basically how it works. So we back in these quadrants, quadrant 1 and 4. So this should be okay. Retabile, if we look at this question, because I'm going to explain, because I think you're definitely not the only one. In this trig equation, cos is positive. So cos of alpha minus 25 is positive. There's no debate about that. That is a statement of truth. So when we get our answers, we can only get answers in the quadrants that are positive, which I'm saying are going to be quadrant 4, because the cast diagram tells me that cos is positive here. So there'll be a triangle and an answer in that one and an answer in this one. Now, all angles in this quadrant have that form, and all angles in this quadrant have that form. So what I'm doing is my quadrant 1 answer is 45, but my quadrant 4 answer is going to be 360 minus 45. However, this is not finished because we're doing a more complicated trig equation, but we're almost there. Now what we need to do is we need to incorporate this bit. And the way we do that is we say alpha minus 25 is 45, or alpha minus 25 is 315. So it's just that subtle little adjustment. So it's not like it's still the same method. And now this minus 25 needs to go to the other side. So we add 25, and so alpha is 70, or alpha is, what's 25? 340. Or did I make a mistake there? No. Because remember, at the moment, I see a couple of you are getting caught by this. If it's minus on this side, I need to add 25 on both sides to get rid of that. And so I get the answer of 70, and on the other side here, I get 340. Yeah. So alpha is 70 and alpha is 340 of the two answers. If you want to make these solutions, these are specific solutions, and these solutions are in the range 0 to 360. So see, like the one answer is 70, the other answer is 340. If you wanted to make them a general solution, you would just tag on a k times 360 for the period of the cos graph. And the reason it's cos we're dealing with is the question dealt with cos. Okay. Again, if you're not getting it, don't be discouraged. This takes lots of practice. But the good news is once you've practiced it enough, the method doesn't really change. So what I'm going to do now is I'm going to ask you all to stand up because we've been working really hard and I think we need to have a quick break. And I just want everyone to just stand up. I'm not going to do anything too silly unless, Coco, you can think of something silly. But I just want us to stand up for a moment and just, I don't know, take 5 deep breaths and just appreciate the fact that you're learning about the mysteries of trig equations. Coco, do I detect the smile? I think it's always good to pause before we move into the second part of the lesson.
I agree with Cameron. Cameron says, so trig is actually easy. It is
Cameron,
when you know exactly how to do it. Yeah.
So the key is to have these well-formed procedures that you can follow that you've practiced a lot, because then that will, you know, it makes it look less scary when you've got the maps of things going on. Okay. I think we're going to leave trig equations for now, and we are going to move to trig identities. Okay, so you can see the other questions. You can practice that more in your own time, but let's do a trig identity question, that very common one. Now, I am going to do the one in white, and then you guys are going to try and do the one in yellow afterwards. So that's how we're going to do this. And the trig identity that this involves is something called the reduction formula. So you'll notice that at the very beginning, the question has the sine of 17 is equal to a. Express the following expressions in terms of that original. And the problem I have is that this 197 is not an acute angle. It's a really big angle. The same problem with 2.2, the same problem with 3, 4. In fact, I'm actually only going to do 2.1 and 2.3 because I haven't touched on the vertical reduction at this point. So I'll just keep it at that one. Okay, so if you think of the sine of 197, that sine of 197, the nearest horizontal is going to be in quadrant 3. And so you can imagine that if you imagine 197, it's made up of 180 for this part, and then 17 for that part over there. Now, because of the cast diagram, in this quadrant, sine is negative, and so this would reduce to minus sine 17. Now, the good news is I've got sine of 17 here, and I know the sine of 17 is just a. And so the answer to my question, to express the following in terms of a, is just going to be minus a. That's it. For 2.3, we are now no longer in the same quadrant. We are in quadrant number 4. And if I go all the way around to here, in this quadrant, tan is negative. So I know my answer is going to be negative. But how far is 343 from the nearest horizontal? Well, good news is it's just 17 away, because this whole big angle was 343. And so this is going to be minus the tan of 17, which actually, again, is going to give you the answer of minus a. Okay, so that's the basic idea that I want you to use. I would like you to try and do the same for 3a and 3b. And I want you to try and do that now. I will give you some time. And then once you have, let's say 3 minutes, But if you have a question, now is your chance to ask an audible question or to put it in the chat. I'm happy to help. I just don't want to talk too much if it's distracts you from doing the work, if that makes sense.
DeAndre has a question.
Go ahead, Andre.
Why is it just negative a and not negative sine a?
Okay. So there's a substitution that's happening where at the beginning, there was sine 17 is a. So essentially what I'm doing is I'm saying in this question, minus, this is the same as, this is reduction formula, minus sine 17. This part over here, the sine 17 is a. So basically, I'm just switching sine 17 for a because they are the same thing. And then there was a minus sign in front, which means it became minus a. So I hope that helps a little bit. Retabile, go ahead.
Retabile, would you like to unmute and ask your question? I can help you unmute. Oh, I'm not getting oh, there we go.
So sine 17 is in the fourth quadrant. So sine 17 isn't in the fourth quadrant, but 343 is in the fourth quadrant. So if we look, if you think about when we start measuring angles, we start 0 degrees is here, and we get to 90, 180, 270, 343. And so what I call this is, I call this the generating angle. This generates the triangle that allows me to do trigonometry. But if your generating angle was 343, there's no way 343 fits inside a triangle. And so the key thing is we say, how far is this red angle from the nearest horizontal? And it's 17, because the whole way around would be 360. So the tan of 343 will be in quadrant 4. So I hope that helps a little bit. And tan is negative in the fourth quadrant. Yes, that is important. So we'll do this in a moment when we look at the example one. So where is tan of 140? What quadrant gets tan of 140? Well, I think it's in this quadrant. And so if that's 140, and don't be afraid of drawing in your cast diagram. In quadrant 2, tan is negative. So if I'm dealing with this one over here, I'll just do above it. It's negative tan something. The next question is, how far is 140 from the nearest horizontal? Well, the nearest horizontal is 180. So the angle here is 40. And so this would be negative tan 40 on top there. But you've still got to deal with this part over here. Okay, so what is 3 tan 220? Let's work that out. So you might need to draw another cast diagram now. I think I'm in quadrant 3. Oh, but that means it's positive. So this is 3 tan. So this is plus 3 tan 40. So what have we got? We've got minus tan 40, which is minus t, plus 3 tan 40. And remember, tan of 40 is t. So 3 tan of 40 is just going to be 3t. And so the answer for A should be 2t. Let's see if we can do. Are there any questions or comments about A? So yeah, so 3 tan, yeah, so 3 tan 180 plus 40 into cosine, you're exactly right. But can you see how the substitution is what I'm worried about for you guys. Can you see how t is defined? So over here at the very beginning of the question, it says t is tan 40. So now once you've done your reduction, wherever there is a tan of 40, I'm replacing that with just a plain old t. And then I go minus 1t plus 3t is 2t. Sounds like a bit of a tongue twister. T, how many t's does tan have on a t? I don't know. It's trying to be too clever and it's too late in the lesson. So let's try and do this last one. This is a little bit sneaky. Yeah. So I might have to do a little bit of, since the nearest horizontal from 220 is 270. Oh, okay. So Teddy, we are only, remember 270 is a vertical. So we haven't gone, yeah, we haven't used the other reduction. So we will cover that in a future course, but for now I wanted to just keep it simple and use the horizontals. So the horizontals are at 180 and 360. And you're talking about a vertical. So at this stage, okay, I'm going to have to be a little bit sneaky with this one, is that okay, you guys aren't going to like this, but basically I'm going to times the top and bottom by 1 over cos 40. And what we're going to get, okay, you're going to have to trust me on this. You're not going to love it. But for now, it's basically, if you got to that stage, I'm happy. But like instead of me going further than that, let me just leave it at that point. At that point, if you've done that, you've understood the reduction formula, and that's not a problem. From there, I'm going to be timesing things in weird ways that isn't really going to help if I go further. What would it be wrong if I changed it to tan? So, okay, in terms of the question as it's written, they do want to write it in terms of tan. But the problem is we need a way of getting cos over sine. We need to flip this. Okay, I will show you. So imagine this. Imagine I times the top and bottom by 1 over cos 40, which is going to seem a little bit weird. Okay, so if I do that, I'm timesing the top and bottom by the same thing. And what I get is I get negative cos 40 over cos 40 on the top. And then on the bottom, I'm going to get sine 40. And I'm going to get that. Now, I did that because I really wanted to get sine over cos, which is tan. What is cos of 40 over cos of 40? It's just 1. And so we end up with minus 1 over, and what's this thing over here? Sine of 40 over cos of 40. Well, that is just going to be tan of 40. And at the very beginning, what did we say about the tan of 40? We said t is the tan of 40. So the answer would just be minus 1 over t. However, I've made that question harder than it needs to be because I haven't used the vertical. And so I don't want, if you feel unnecessarily stressed about that, then just let it wash over you. There's no need to feel stressed. Would it be wrong if I multiply by the reciprocal to get sine 40? No. So you can do that. Yeah, no problem. So what I did was I multiplied the top and bottom by 1/40. And the reason I did that was it allowed me to move the cos of 40 to the bottom. And then essentially it made this lovely thing happen, which is that. But again, I'm not going to linger on that because I think that is, as you do more and more of these, it'll become more familiar. For now, all I wanted to do was just check that reduction formula. Okay, let's do one more. Let's end the night with one question like this. I want you to simplify this expression. So remember at the beginning of the lesson, I gave you what was called the quotient identity and the square identity. Can you simplify? Maybe we'll squeeze in two more. Can you simplify that expression over there? So can you simplify that expression for me over there? Yeah, let's finish with that one. Yeah. So what does this ring any bells? That's what I want you to think about. What can you replace that with? So at the beginning of the lesson, we spoke about this identity. Oh, let me get rid of all this other stuff over here. So sine squared b plus cos squared b equals 1. And so if you had 1 minus cos squared b, can you see how you could just move this across? And so I think that the bit in yellow can be replaced by this over this. But now we've got another step to do. I see some answers coming through. Let the answer. So this is not an identity. This is an example of an expression that you're simplifying using an identity. But I will show you. We'll squeeze in one more identity question then. Okay. Now the second bit is, what is sine squared b over cos squared b? Well, that is an example of the quotient identity, and so that is going to be the same as tan squared b. But what is tan squared b minus tan squared b? Well, anything minus itself is just going to be 0. And so that's it. Let us, I don't know if we're biting off more than we can chew here. Let's try and do this last identity question now. Yeah, let's do it. Yeah. Okay. When you work with, this is a trig identity, and you have to show that the left-hand side is the same as the right-hand side. And so what you always do, a good technique, is start with the more complicated side and work with it by itself. So you start by working with the left-hand side and show it looks like the right-hand side. So I want you to first think, what is the first thing, identity, that you notice that maybe you can use in this trig identity question? And that's a good tip for future. If you do trig identities, you start with the harder side, and then you work with it to make it look like the positive side. Then Coco, if I could just ask you to get the quiz ready so that students are, yeah. So you're right. So you're right to hone in on this bit. So essentially sine squared theta plus cos squared theta is actually going to be the same as 1 plus tan squared theta. Okay, now the problem we have now is this doesn't look anything like this yet. And so I want to ask you, what can we do? What other tools do you have in the toolkit that maybe we can get a cos to pop out of the woodwork? And I think we can make tan into sine squared theta over cos squared theta. And the good news now is that at least we have a cos squared theta here and a cos squared theta there. But I want you to think back into your knowledge of algebra. What can we do to bring these two together? Ms. Coco or anyone in the chat, what do you think we're going to do to bring those two happy people together? No, so all we need to worry about is when we add two fractions. Yeah,
I think we might need to find an LCD. Yes, I think Mamelo beat me to it, but yes.
Okay, perfect. So the problem is this lonely one. It's this one. What we need is we need a common denominator, and we need to force the common denominator to happen. So there's different ways of doing this, but basically, I suppose one way of writing it is you write down your common denominator, which is cos squared theta, and then you say, well, what did you need to do to make that happen there? You times the top and bottom by cos squared theta, so you get that. And then the other fraction, you had cos squared theta at the bottom, so now you just go like that. And then it hits you in a flash of insight. What is cos squared theta plus sine squared theta the same as? Well, I've seen that before. It's just going to be 1. And so the good news is you've now found a path, because at the very beginning, the right-hand side was 1 over cos squared theta. Now, I've done that quite quickly. So if you felt a bit overwhelmed, then, don't stress. It's a journey here. But I'll just point out what I did as a summary. I worked with the more difficult side. I looked for either the square identity or the quotient identity. In the case of the first one, I replaced the 1 for this bit here. I then said I'm stuck. So I changed the tan into this. And then with a little bit of help from Coco, we figured out that now we need to add these fractions together. And the way to do that is to find a common denominator. And then the last step was to recognize that this was 1. Okay. All right. Trigonometry is a big topic. These 8 lessons aren't by themselves going to do the whole area, but it does give you a nice grounding in getting busy with trig, and it's a big part of your matric syllabus as well. And so I think we'll just keep hacking away at this, building up knowledge as we go. Okay, Coco, I think that is all from me. I think we can put the quiz in the chat for students. If you want to ask any more questions, I will stay around for a minute or two more. Otherwise, once you're done for today, I would suggest go off and do the quiz now, and then I will see you next week, Monday. And I hope today was, I hope that we helped you kind of build up a bit more knowledge as we went.
Before we do that, I still do need to just run the poll quickly. So guys,
okay,
let's. And in the meantime, after you've answered that, I'm going to pop the link to the quiz.
Let's just do the poll, and then we'll do the quiz after that. Thanks for reminding me, Coco.
No problem. It's taking a while. There we go, guys. If you can just answer that one question that just popped up on your screen for me. And then once you're done, you can have a look in the chat. And the link to tonight's quiz will be there as well. Okay.
Yeah, so this just helps us if we offer more support for exams. It's very helpful for us to know when your exams are, and so for planning. So that's why we're asking this question. And then enjoy the quiz. it should be, yeah, it's just a nice way to see kind of what you're retaining from the lessons. Kitty Bona, go ahead. I see your raised hand.
Sir?
Yeah.
The previous question that you did.
Yes.
What happened to the brackets? Why did you remove the brackets?
Remove the brackets?
The previous
So
question.
not this question, the one above here.
Yes.
Okay. So first of all, in this question, the brackets, are you okay with how I replaced how this suddenly appeared?
Yes, sir.
In place of this?
Yes,
okay.
sir.
So once I got to this stage, you're right, the brackets weren't there anymore, but they didn't really serve any purpose. So essentially what happened was sine squared b over cos squared b is tan squared b. And so the brackets don't really do anything because there's only the numerator has been simplified. The bit in green has been simplified. And so all the brackets have is a 1 outside, but it doesn't really do anything. And so that's why I could take, I multiplied out the brackets with the 1 being outside. And so that's how I could go the next step to tan squared b. Basically, this became tan squared b. And then that was tan squared b. And then together, anything minus itself is 0. So that's kind of what I was doing. Okay.
Oh, okay. Thank you, sir.
Pleasure.
Bye.
Okay. Ciao. Another question?
Sir,
Yeah.
I have a question regarding
Go ahead.
the general solution.
Okay.
Let's say the question is its sine squared is equal to cos x plus 90.
Okay, so sine squared x, would that be your question?
Yes.
Okay, so that is what that's a different level of trig equation. So the first, there's a number of problems. The first problem is that this is cos and this is sine. So you would have to convert that into a sine. The other problem is this is squared. So I think, I would have to check if that is a reasonable, let me have a look. Sines, what would I do? I could change this into a cos. Okay, so you're going to have to use I would probably change this into cos 90 minus x. And then that would be squared. Yeah, okay, so this is a much longer question, but the main problem is that you need to get the trig ratios to be the same in this particular question.
Yes.
And so once you've done that, you are then going to now work with, can you equate these? These are squareds. No, you still need to bring it across. I have to think about it off the top of my head, but there's a couple of problems and you would have to kind of approach it with a set of technical issues. If it wasn't a squared, if it was just cos 90 minus x equals x plus 90, you could equate them. But the square is worrying me a little bit. So I'm going to have to think about it. Off the top of my head, I'm not 100% sure at this stage, but I can have a look at it, but just check that it is a proper question. Okay.
Okay, sir.
Yeah. Then we can go from there. I've taken a screenshot so I can, let me see, I have got one. Okay. Yeah. All right. I think we're going to wrap it up there. Thank you very much, Coco. And then I will see you guys all on Monday. And if you could just post it in Slack.
Yes.
Ciao. Ciao.